Hello, this is Mike at GameFromScratch. Today we're going to be taking a look at using GLSL shaders in Phaser. It's a little bit inaccurate because we're not actually using full GLSL shaders. We're actually only going to be using fragment shaders. And in Phaser parlance, shaders are actually called filters. They inherit that from the library pixie.js that they use for their rendering. If you've never heard of it, Phaser is a excellent, complete HTML5 game library or engine. Not a lot of tooling, so I guess it technically falls on the library side of the equation. But it's an excellent, excellent library. If you go to GameFromScratch.com, I actually have a full tutorial series on using Phaser with TypeScript. I've also did an earlier two-part video on creating a complete game from scratch using Phaser with TypeScript. So I'll link those in the comments below if you want to watch more videos on how to actually work with Phaser. But for the most part, this video is going to assume you've already got some experience. Now the challenge is the TypeScript integration. TypeScript's a great language. It works over a lot of the warts of JavaScript by adding a type system on top of JavaScript itself. It ultimately compiles down to JavaScript, but sometimes you're left wondering how the heck to do something, and the topic of filter usage in Phaser was completely uncovered. I've actually done a text post equivalent of this available on GameFromScratch.com right now too. I'll also link that in the comments. So if you want the source code or whatever of what I'm about to build, it's all available there. So without further ado, let's jump right in. First thing we're going to need to do is create a project. I'm in Visual Studio here. I'm going to create myself a TypeScript project. So HTML application for TypeScript. Here, we'll throw this in temp for now. We shall call the Phaser shaders. Phaser shader works for me. And build it. Give it a second. This will create a stock app for us to work from. Here you go. So it gives you this this app.ts file that's created by the simple index.html right here. All this really does is loads up, and inside the at the end it calls your app.js, which is the generated file from this ts file right here. We need to add a couple things here. We're going to also need to include in the Phaser specific libraries, and that means grabbing them. You can grab them from Phaser, but I'll grab the most recent ones from the Git hub repository. So the Phaser GitHub is github.com/photonstorm/Phaser. And then you go into the build folder. This is where you'll get the most current releases. And the files we want are phaser.js and possibly .map. So we'll just go ahead and grab that. So just click it, right click the raw, and bring that into your project. That's the right folder. Let's save that, and I will grab the map just in case. And then finally, we want to go back to the root here and grab the TypeScript libraries for it too. Now they've been split out a bit, so now the physics stuff is in a separate file. However, you still need it or you're going to get a bunch of errors. So even though you're not using the physics library, just go ahead and grab that one. The main definitions, these are just TypeScript to HTML5 definition files. And we'll grab the Pixie one just in case. So this gives us all of our various types, so it maps between JavaScript and TypeScript for us. The nice thing is they are provided, so we don't have to do this work. So that should be it. Head back to our project, and we'll just add those in. All right, so that one, that one, that one, that one. All right, so we now have all of our libraries included. We just want to go ahead and make sure that they're actually being loaded when we start. When our HTML file, this is the file that actually kicks everything off, and we just need to go ahead and make sure that the Phaser library itself is being called. Okay, so that should be all we need to change from this HTML file. And now it's time to get our app up and going. Let's strip this down to the bare essentials to start with, and then we'll work back from there. Class, go away. All right, we'll go with that. So first, let's reference our library. D.ts. Close and done. Okay. So now class, I'll go with, we'll stay consistent with what I did online. Simple game. So we're declaring our new class, our game class. And let's do a couple members here. First we have our game, which is type phaser.game, like so. We're going to have an image, phaser.sprite, like so. We'll call that guy, sorry, image. Okay, so there is our simple class, simple members. We're going to bring that image in now. I'm just going to use the GameFromScratch logo image. Just drop that over there. Okay. Use whatever image you want, obviously. That one's easy and available for me. And eventually we're going to have a shader here, but we'll come back, we'll edit this code after the fact. First, we just want to make sure that our app is up and running. So we want to have our image up and displayed and nothing else. So let's create a constructor for our class. And, oh, sorry about that. Here, let me make it so you can actually see what I'm doing. Oh, you suck. 1 second. All right, working now. Hopefully you can see a little bit better. Also, zoom this source code in a little bit. There. So hopefully that's a lot easier to read on the video now. I keep forgetting to kick into present mode when I'm doing this stuff. Okay, so now inside of our constructor, we're going to go ahead and create our game. New phaser.game, 640 by 480, and auto sizing. That's the name of the HTML element to draw our game into. And close that off. And now we're going to tell it what methods we implement. Do a create, and this dot create. It's going to error out for now because that's not actually defined. Preload, this dot preload. Again, it's going to error out. And render, this dot render. Okay, so we're going to have to provide each one of those methods now, obviously. So we're at the end of our constructor. Now let's just go ahead and do preload. We'll do, oops, I suppose I should stay in order. Create, preload, and render. Ooh, hey you, render. Why are you doing that in IntelliSense? Okay, so there are our three methods. Now we want to go ahead and in the preload here, we're going to bring in that image we just loaded earlier. So this.game.load.image, we'll call it logo, and it's GFS logo.png, I believe. Yes, it is. All right, so that loads our image into memory when we first start up. Now in our create call, we're going to go ahead and actually use that asset to create a sprite. Sprite up here called image. And all we need to do there is go this.image equals this.game.add.sprite. We'll create it at the origin, and we're using the key logo because that's what we called it here. So our image is now loaded, and that should be about it. So now finally we have to do one global script here, and this is to actually wire this up to do something. The other thing I got to make sure is that we have a div named content. Let's go back here. Content. All right, perfect. So that's already wired up. Now, after our class is declared, we just want to do a window.onLoad event equals then arrow function. So this is called onLoad is var game equals new simple game. And this just creates an instance of our class, kicks everything off and running. So this is the browser's document.window.onLoad function, and when it is called, we just create an instance of our game class. Now, theoretically, I've done this all right, and this will work. There you go. So there is our window, our app, our image being drawn. I forgot to remove some header text, but otherwise, we appear to be working just fine. So if you've never seen a phaser application before, that is an absolutely basic one. Again, I didn't go into a lot of detail defining it. I will link to a tutorial where I do, or you can go to the web tutorial on GameFromScratch, which I'll also link. So the details of how all this stuff works is available elsewhere. Oops, wrong guy. Okay, so now that we've done that, we want to go ahead and actually add a shader to our game. And this is going to involve creating a couple of classes. I'm going to do them out of order. We'll do them all in the same file, though. First, we're going to create our shader. And this is phaser.filter, like so. So one of the nice things about TypeScript is you got this inheritance mechanism here instead of a prototype type. I won't call it a hack. That's not really fair, but a hack, which basically what it feels like. So we'll create a constructor. It takes a game. It takes uniforms. Which are parameters that are passed into a shader. In this case, we'll give it an any. And the source code of your Fragment Shader. Now, if you know anything about GLSL shaders, I'll give you a quick overview of what we're doing here. We're actually dealing only with the Fragment Shader. With 2D graphics, there are normally two available to you. There's Fragment Shaders and Vertex Shaders. Vertex Shaders are responsible for positioning and translating vertexes in 3D and 2D onto your screen. Now, in the case of Phaser, that's not really that particularly useful because generally all you're dealing with is quads. Your sprites are just a texture quad, so you've really only got 4 vertices in every case. So even doing changes to vertexes, it's just going to screw things up. It's not generally what you want to do. Now the other thing you've got is a fragment shader. A fragment shader can also be thought of as something called pixel shader. And what it is responsible for, it's like a mini program that runs on your GPU and is run for each potential pixel on the screen. And its entire output really is just an RGBA value that represents the pixel to be rendered. That's it. So through the magic of shaders, we're actually going to, we're just going to do a simple modify of an existing phaser one and make every pixel gray. So we're going to grayscale our image in this particular shader. But you can do all kinds of things. You can create images on the fly. You can create fire, smoke effects. The sky's the limit almost, but it's programmatic pixel generation basically is what a fragment shader does. And a uniform is the parameter passed into said shader. Now some of them are provided by Pixie or Phaser, and in this case only one of them is actually going to be provided by us, and we'll see that in a second. Now the shader source is being passed in as either a string or a string array. In this case we'll go with a string array. There's a library out there that enables you to load shader files as entities. It's a nice way to do things, but in this case we'll just go with the array version. What have I screwed up here? Oh, I haven't. I'm just not finished yet. Alright, here, I'll just let it do that so it can shut up. This dot game, this dot uniforms, this dot fragment source. Like so. Okay, why are you all pissy? Alright, we'll get to that in a second. So, first things first, actually, you know what, I'm doing this completely out of order. I'm going to add something else here. We also need a class called uniforms. This is those parameters we're passing in. So I'll go ahead and create them now. I was going to create it later, but it doesn't really make a lot of sense. So this is the parameters that we're passing in. And we're only passing in one called gray. And we'll give it a type any because I'm extremely lazy. So I'm going to need this guy ultimately, so I'll go ahead and do it up front. So this is the parameters to your shader. So back to my constructor now because I'm actually going to need that right now. As this dot uniforms equals new uniforms, and then this dot uniforms dot gray equals the type and the value. So basically a 0 to 1 value, 1 being full on. All right, why are you so angry? Oh, IntelliSense is being very dumb to me. All right, so that's defined. Now we want to go ahead and define our shader. Why are you all angry about that name? Did you want... This is simply a string array defining our shader source code. And let's get started. Okay, so first thing, shut up email. Tell the level of precision to use. And then here are our uniforms. Now these first ones we're going to do are needed for phaser or pixie to work right. So first one is a vector 2, and this is the texture coordinate. Like so. The next one is vector 4, appearing the color. And the next one is a very weird way. It's GLSL parlance, but basically this is your actual texture. And then finally, the value we are going to use, uniform, it's a floating point value, gray. So this is that value being passed in right here. All right, so that's our parameters. Let me just leave a line. And then now our shader entry point. And then GL frag color. This is that fragment color. This is the ultimate output of your shader. You use texture 2D function on the sampler, basically saying, and then pass in the texture coordinate. So basically saying, get me the current color of the current pixel at the certain coordinate within the texture, essentially. So this is sampling through the texture. It'll be called over and over and over again for each potential pixel. This is saying, give me the appropriate colored pixel within the current texture map for right now. And then once we've got that, we want to go ahead and set our output color, RGB value, and we're going to use a built-in function called mix, and glFrag color.rgb vec3 0.2126 glFrag color.r plus 0.7152 times glFrag color. So basically we're multiplying each value of the RGB, so the red, the green, and the blue component, by a number to give us a nice grayish tone as opposed to its current value. Unless, of course, its current value is gray, in which case it will do basically nothing. So R and then G, right? So plus 0.0722 times glFrag color.blue, then our gray value. So that's what we're mixing each of those values by. The gray value we pass in. Because I scrolled, no doubt I've made an error in there somewhere. But we shall find out. And then finally, let's close this sucker off. So, and our array ends. Why are you upset? I missed a comma. That'll do it. Okay. So in theory, I didn't make any typo errors, and this is your shader. Now, if you're new to shaders, first off, there's a link on GameFromScratch.com that gives you links to other links about GLSL. I'll also link that in the comments. You can also go, there are a pair of sites, Shader Toy and Shader Frog, which are a source of huge number of shaders that you can pick up from there. So there's a lot more detail you can get elsewhere, way beyond the scope of what I want to cover here. But in theory, that is our shader defined. All it really does is sets up its parameters, creates the source, and then calls its base constructor, more or less using the functions that we just defined. So now that that's done, let us apply our shader, and that is done to our image. So our image is loaded here. Remember I said shaders are actually called filters in the world of Phaser. So what we want to do is this.image.filters. Notice it's plural. And so you can pass in an array of filters, but we actually only have one. So we're just going to go ahead and go new my shader. And it takes a this.game and a pair of other values that aren't actually used. We could actually remove those from our version, but we're just staying consistent with the base class. And I think that's it. So in theory, if I go ahead and run this now, oh, I did make an error. Okay, break. Where's the error? This image.filters. That all appears valid. All right. Chances are I did a typo somewhere in my filter. Let's actually see if we run to that point. All right, so it's definitely being loaded. This.game is undefined. Okay, that's probably our problem. Why is game not defined? Oh. This.game news new game. Okay. That should be fine. I don't get what's going on here. 1 second. Okay, this was weapons grade stupid. First off, change this.game to being game. We're just passing through. I didn't take a copy of it inside of the shader, so just hand this parameter straight through. I don't know that it's actually going to be used in the end, but my ultimate error was actually this guy. Preload is where you load your image. Create is later on in the life cycle, and this is where you actually created your sprite. And I just did this in the wrong area. So I tried to apply a filter to a sprite that did not yet exist. So this might be a little confusing. This actually comes in the life cycle before this, and this comes before this. So I have a really weird ordering going on here. You should probably technically have ordered your code more like this. A little bit more logical. Not that it makes any difference what order it's in, but I kind of screwed myself up there by not ordering it correctly. So basically, lifecycle-wise, create comes after preload. So I hadn't created my sprite yet, so I tried to apply a sprite to a non-existent object. So now let's see if that's right. I still have my debug point. Let's continue. Okay, so our filter is definitely being applied. It's just not right. So let me just fix that up quickly. All right, and we got another typo. And just this guy. Told you. I scrolled, I was going to screw up, and I did. So that's the downside. When you do your authoring, use one of the tools in the link I'm going to provide for shader programming. Don't do your shader development this way, or you are going to go absolutely bonkers insane. So there are much better tools for writing code than doing it as an array of. So do it in a shader authoring tool and then copy it over, or use the linked version for bringing it in as a resource. Don't do it this way, or you'll go absolutely insane. But in theory, that was probably the only error. Let me go ahead and run that now. And ta-da, we now have a grayscale image with a shader applied. So there's a couple things to take away here. First off, shaders are called filters. The shaders are actually just fragment shaders. Basically GLSL underneath. Now that brings up an important point. Phaser and the underlying engine Pixie both allow you to do a fall-through rendering for to the canvas. So they use GL if available, canvas if not. Shader programming or filters will not work in that case. So there's no fall-through here. This requires WebGL to run, period. So that might be kind of a deal breaker for some of you. Hard to say. Let me shut that down. But that's about it. Hopefully that was useful. Again, there will be a bunch of links in the comments at the bottom. So if you want to learn a little bit more, please stay tuned and check out any of those. Hopefully that was useful. Thank you very much. Bye.